Hi everyone, welcome to Mr. Wagged's math class again. Today we will continue talking about transformation, and if you remember, the umbrella is the transformation, which is changing a figure in a coordinate plane. Under it are the different ways to transform a figure. The first one is translation, which means sliding. The second one is reflection, which means a flip. The third one is a rotation, and the last one is dilation. Today's lesson we will talk about rotation. So what is a rotation? Rotation is a turn. Just like the first wheel when it turns, or like the wheels of the car turns too, or even like the earth turns around its axis 24 hours a day. That's why you have day and night. But the most important turn when we talk about transformation in a coordinate plane is the clock. So here's the clock. When you go with the clock, that's called clockwise. So you're turning right, which is clockwise. If you're turning left, that's a counterclockwise, which means against the clock. Also, the clock creates 4 quarters. In the coordinate plane, they called quadrant. So with the clock, if you turn from 12 to 3, that's a 90-degree angle. And it's a clockwise because you're turning with the clock. But if you turn from 12 to 6, clockwise, that's a 180-degree angle. What if you go to the 9, from 12 to 9? That means you turned 270-degree angle. And if you go all the way back to 12, that means you turned 360-degree angle, and it went back the way it is. So remember, going right is clockwise with the clock, and going left is counterclockwise, which means against the clock. Now there are 2 things I need you to think about when we're talking about rotation in a coordinate plane. The first one is the center of rotation, which is this center in the middle where the object rotates about, so it does not change. It stays fixed. Or the degree of rotation, which is the number of degrees an object rotate, whether it was 90 degree, 180, 270, or 360, going back the way you were. Now I want you to grab any book. And this time I grabbed a book that says Angels Don't Know Karate. And it has a picture in writing because I want you to see the orientation or to see how it turns. Now hold on to your book in one corner, and that is your center of rotation. And I wanted you to rotate this book 90 degrees. Whether you go clockwise or counterclockwise, it doesn't matter. I just want you to rotate it 90 degrees this time. And a 90 degree literally means a 90 degree after the turn, and before the turn, it made a 90-degree angle. And now turn it 180 degree, which made a 180-degree angle, the original with the after the turn. Keep the center of rotation the same, don't change it. And now turn again, and that another 90 degree, and that makes 270 degrees. And turn one more time, 360 degrees, and it went back the way it was. Now let's answer those questions. Did the size change? No, it's the same size, same book. Did the shape change? No, it's still a rectangle. Did the orientation change? Yes, it turned. It doesn't matter how many degrees, it turned. So corresponding sides, all the sides, and corresponding angles, all the angles, are congruent angles. Therefore, rotation proves congruency. So the image and the original still have the same size, same shape. Now let's see if we can find the rules of rotating a figure in a coordinate plane. And if you can come up with a rule from one point or coordinate pair, it works for any vertex on any polygon that you wanted to rotate in a coordinate plane. So let's start with this original coordinate pair, 3 and 6. X is 3, Y is 6, which is this purple dot. And I wanted you to rotate clockwise. Remember, each quadrant makes a 90-degree angle. From the first to the fourth, that's a 90-degree angle. From the fourth to the third, that's a 90-degree angle. From the third to the second, that's another 90-degree angle. And then from the second to the first, that's a 90-degree angle. So each one makes a 90-degree angle. Keep that in mind. So rotate this 90-degree clockwise. Where would it land? The center of rotation is the origin, which means the original dot with the center of rotation needs to make a 90-degree angle with the image. And that's where it would land, the red dot. The coordinates after the 90-degree rotation is 6, -3. Watch what happened to x and y. They switched. The x becomes the y and the y becomes the x, and then the y became negative. Now I need you to rotate the original dot, which is the purple one, 3, 6, 180 degrees. That means you go in 2 blocks, 90 and 90, 180. Where would it land? The purple dot with the image 180 degree, passing the center of rotation, they have to make 180 degree, and they did. So the red is the image after 180 degree, and it landed at -3, -6. Watch what happened to x and y. The value of x stayed the same, the value of y stayed the same, but they both became negative. Now, the last time, rotate from the original 3, 6 all the way 270 degree, which you will land in the second quadrant. And you have to make in 270 degree the original with the image. Now, the new image coordinate will be -6, 3. Watch what happened when you went 270 degrees clockwise. X and y switch, the x becomes the y and the y becomes the x, but now the x is negative. And that's a lot to remember. All you need to know, where was the original? And after the rotation, how many degrees, where would it land, and what are the signs? And you will know what are the new image. Okay, now let's go counterclockwise, which means you're going left on the coordinate plane. Same origin, 3 and 6. Now you need to go to the left counterclockwise, which means you are going to land in a second quadrant if you go in 90-degree rotation. And the center of rotation is the origin, so that's fixed. It doesn't change. That's a fixed point. But you have to make a 90-degree angle with the original and the image passing the center of rotation. And it did. Watch how the new image, the coordinates of the new image are -6, 3. X and y switched, but now the x is the negative. 180 degree, you will land in the third quadrant. And you have to make 180 degree, the original center of rotation and the image. And the coordinates would be -3, -6, because it landed in the third quadrant where x is negative and y is negative. But the value of x and y stayed the same. It's still 3 and 6. 270 degrees the same way, counterclockwise means going left. And you will end up in the fourth quadrant. You need to make a 270 degree angle, the origin with the image passing the center of rotation. You end up with 6, -3. Again, x and y changed or switched, but the sign of the y became negative now. And then that's why I said at the beginning, you don't need to memorize all these rules. All you need to know is which quadrant the original was and where did it land. Here are the rules of rotation. If you like to apply the rules and remember them, clockwise, 90 degree, 180, and 270. And counterclockwise, 90 degree, 180, and 270. If you notice something, the 90 degree clockwise is the same as 270 counterclockwise. And the 180, whether you go clockwise or counterclockwise, they have the same rule. And 270 clockwise is the same as 90 degree counterclockwise. You don't have to memorize all this, but if you wanted to and you like to apply it, go for it. But I'm going to summarize all this into 2 rules. The first rule is if you're rotating 90 degree or 270 degree, they have the same rule. Switch x and y, and the sign depends on the quadrant it lands in. If you are rotating 180 degree, just change the sign of x and y. and those will be the coordinates of the new image. All you had to do is plot them. Okay guys, there's a second part to this lesson, to rotate a figure in a coordinate plane on a whiteboard. More practice to rotate or use one transformation, such as rotation, followed by translation. Thank you for watching. Have a great day.